to our core IaaS series. I'm Andrew Chen, Principal PM at Microsoft. Today, we're focusing on one of the most critical pillars of cloud resiliency, storage. In the AI era, data is truly the lifeblood of every organization. And whether you're running analytics, powering applications, or safeguarding intellectual property, your business depends on the availability, durability, and recoverability of your data. Azure Storage is engineered for resiliency. It's designed to anticipate failures, absorb disruptions, and enable rapid recovery. In this session, we'll explore the principles, features, and best practices that keep your data safe and your business moving, even when the unexpected happens. Let's start with the fundamentals of Azure Storage resiliency. First is redundancy. Azure always stores multiple copies of your data to protect it from both planned and unplanned events. These events can range from hardware failures and network outages to larger disruptions. By maintaining these copies across physically isolated domains and locations, Azure helps ensure there's never a single point of failure. The level of protection depends on the redundancy option you choose, which we'll explore in more detail later. Now let's talk about durability and data integrity. Durability means your data is highly unlikely to be lost or become unavailable over time. Azure Storage is designed for extreme durability. In the case of Azure Blob Storage, the design targets range from 11 nines all the way up to 16 nines, depending on which option you choose. 11 nines durability means that an object has a 1 in 100 billion chance of being lost in a given year. Or, to put it in perspective, it's like a watch that loses 1 second every 3,100 years. That's how seriously Azure takes protecting your data. Azure achieves this not just through redundancy, but by also validating every write operation using checksums and other integrity mechanisms. When data is written, Azure verifies that it's stored correctly and then continues to run background integrity checks to detect and automatically repair any silent data corruption or bit rot. These ongoing processes work together to keep your data healthy and accurate. Finally, let's talk about rapid restore and recovery. Azure provides several ways to quickly recover from accidental deletion or corruption. For individual blobs, you can use snapshots to roll back to a previous version. For broader scenarios, like restoring an entire dataset or container, features such as soft delete, versioning, and backups offer additional layers of protection. So if a developer accidentally deletes a critical dataset, these capabilities make it possible to recover the data and get back to business with minimal disruption. And these principles are embedded in every Azure Storage service, from blobs to files, disks, and data lake. Let's dive a bit more deeply into each. So going a bit deeper on redundancy, Azure offers multiple options to fit your needs. Locally redundant storage replicates data within a single data center, protecting against hardware failures and rack-level events. Zone redundant storage synchronously replicates your data across 3 availability zones, each as its own fault domain with independent power, cooling, and networking within a region, protecting availability against data center and full zone-level outages. And for disaster recovery, geo-redundant storage asynchronously replicates data to a secondary region, hundreds of miles away, which offers protection against region-wide outages. We also offer an option for read access to the region pair copy, even during outages. So why does this matter? Well, if a hardware failure, power outage, or even a regional disaster occurs, your data remains available. For example, during a major storm, a regional outage impacts one Azure data center. But thanks to geo-redundant storage, a healthcare provider's patient records are instantly accessible from the secondary region, ensuring continuity of care. Regarding data integrity, Azure Storage continuously monitors for data corruption and hardware faults, and its self-healing architecture is designed to handle hardware issues automatically. Background integrity checks run automated scans to detect and repair corrupted blocks and prevent silent data corruption. If a disk fails or a hardware component becomes unhealthy, Azure's background processes step in to identify and repair the problem, often before you or your users even notice. The combination of redundancy, proactive monitoring, and self-healing and recovery means your applications and services can keep running smoothly with minimal risk of downtime or data loss, even when something goes wrong behind the scenes. For example, a media company streaming live events relies on Azure's self-healing clusters. Even if a disk fails mid-broadcast, the stream will continue without interruption. Let's now explore point-in-time data recovery. Azure Storage provides a wide range of capabilities to enable the rapid recovery of data that is accidentally lost or deleted, or the reversion of unwanted changes. Soft delete protects your data from accidental deletion by maintaining the removed data in the system for a specified retention period, giving you an undo option for restoring blobs, containers, or file shares. You can set retention periods as long as 1 year. Now, blob versioning allows you to create point-in-time copies of your data so you can roll back to previous versions instantly. File share snapshots protect entire file shares with hourly, daily, or custom snapshots. And managed disk snapshots safeguard VM disks and let you recover from corruption or accidental deletion. How does this work in practice? Well, imagine an engineering firm's CAD files are corrupted by a software bug. The team restores the files from a snapshot taken earlier that day, minimizing downtime and lost productivity. Or consider a SaaS provider using managed disk snapshots so that they can quickly recover virtual machines after a failed update, restoring service in minutes instead of hours. While snapshots and point-in-time recovery provide fast rollback and protection against accidental changes, a robust data protection strategy also requires regular backups for long-term retention and disaster recovery. Azure integrates backup directly into its storage services. Azure Backup for Blob, files, and disks lets you automate backups, set retention policies, and recover data on demand. Vault integration means you can harden your backups in secure, isolated vaults for added protection. And cross-region restore allows you to restore data to any region, supporting compliance and business continuity requirements. Best practice is to schedule regular backups, test your restores, and use Vault integration for mission-critical data. For example, a law firm uses Azure Backup to protect sensitive case files. When ransomware strikes, they restore clean copies from the vault, avoiding data loss and legal exposure. Or consider a global manufacturer that leverages cross-region restore to meet compliance requirements in multiple countries, ensuring data can be recovered wherever it's needed. Now let's explore Azure UltraDisk's Instant Snapshot capability, a feature designed for rapid point-in-time protection of mission-critical workloads. Here we have an M-series VM capable of delivering 650,000 IOPS, ideal for Tier 1 databases like SAP HANA or critical healthcare systems such as patient record databases. This VM represents a production database environment with 12 UltraDisks attached to it to store the database files. We also have another VM called Cloned Demo DB. It acts as a secondary environment where we'll restore data from production snapshots, simulating a backup and restore scenario if the primary system were to fail. As you can see, this VM currently has no disks attached. Next, we'll seed the VM using snapshots from the production environment. Here's the list of snapshots from the production VM. Notice that the access state is set to instant access. In the background, I've started a script to create disks from these instant access snapshots. And as we switch back to Clone Demo DB, you can see that the disks have been created from those snapshots. We've now kicked off an EMR database I/O simulator to replicate a heavy production workload with continuous read and write operations. If you look at the I/O stat, notice the near millisecond response times and approximately 500,000 IOPS across all disks, even while they're still rehydrating from the snapshots. This showcases Azure's ability to deliver consistent, high-performance disk storage during intensive data recovery. For enterprises running mission-critical applications, this means rapid recovery from failures with virtually no performance impact, a capability that was previously unimaginable in any cloud environment. Resiliency isn't just about uptime, it's about protecting data from threats. Azure Defender for Storage provides comprehensive threat protection by analyzing data plane and control plane telemetry to monitor activity, detect threats and malware, and prevent malicious file uploads, sensitive data exfiltration, and data corruption. Beyond the extensive physical and operational security measures that are in place in all Azure data centers, all data in Azure is encrypted at rest by default, preventing access to your data even if someone were somehow hypothetically able to gain access to the physical hardware. Encryption in transit features and options such as private endpoints protect your data in flight. Immutable options for Blob and Azure Backup Vaults prevent tampering and deletion, supporting regulatory and legal hold compliance. For example, a financial institution uses immutable blobs to store transaction logs, ensuring records can't be altered or deleted, meeting SEC requirements. Or a research lab leverages malware scanning to prevent infected files from entering their data lake, protecting sensitive experiments. Not all data needs the same level of performance and latency at all times, and Azure's wide range of access tiers provides both online and offline options, allowing you to move infrequently accessed data to lower-cost storage. For example, Azure Blob Storage's premium, hot, cool, cold, and archive tiers help you optimize costs by storing data in the solution that best meets your needs, ranging from high performance, low latency flash to archive and long-term retention. So an energy company may use the archive tier for long-term retention of seismic data, enabling future exploration or analysis of existing fields. And when new opportunities arise, they can rehydrate the necessary data from archive to premium, enabling rapid analysis once the rehydration process has completed. So let's recap briefly. To maximize storage resiliency, it's important to use zone redundant or geo-redundant storage for critical data. Schedule regular snapshots and backups and test your restores periodically to validate your recovery procedures. Tier your data appropriately for cost and recovery needs, and enable security features like immutable storage and malware scanning. Resiliency by design means your data is always available, recoverable, and protected. With Azure Storage, failures are anticipated, absorbed, and resolved before you or your customers even notice. By leveraging Azure's built-in features and best practices, you can deliver uninterrupted service, safeguard your business, and innovate confidently in the AI era. Thank you for joining the session on storage resiliency.